Okay, so we all like challenges, right? Okay, so here's my challenge. Can I solve all of the types of equations in the first half of Chapter 2 of Algebra 1 in 10 minutes or less? And I have to find a different place within my classroom to solve each equation. Do you think I can do it? Do you think I can do it? Okay. All right, the time starts now. Oh, yes, this is a comfortable spot. Okay. All right, so the first ones are one-step equations, and we have to think about inverse operations or opposite operations. So these are probably, you've seen these for years, so they're probably so easy you can do them in your sleep. So I'm going to experiment to see if they're easy enough to do in your sleep. Ready, set, go. Okay, what did I do? Not bad. Okay, so we're going to subtract 4 on both sides, and then we get star equals 3. Okay, let's see if I can do a better job on this one. So I'll see if it's easy enough to do in my sleep. Ready? Yeah, not bad. N equals 5. Okay, and then remember, you can plug in your answer and see if you got it right. So we can put 5 instead of n. 2 times 5 does equal 10, so we got it right. All right, next spot. Okay, now let's try two-step equations. So this would be like if we have 8x plus 4 equals 28. Like that. 28. Yeah, just like that. Okay. So we need to make sure, remember that x has a close relationship with something, some number. And so we need to make sure x stays with that special number as long as possible. Okay, so I'm going to get rid of the other part. Okay, we got to make sure we do the same thing, both sides of the equal sign. So I'm going to, since we're adding 4, I'm going to do the opposite and subtract 4. And then I get 8x equals 24, right? And then, this is just a one-step equation. Woo. I'm going to divide by 8. And I get x equals 3. Yay! And then I can look back and I can plug my 3 back in. 8 times 3 is 24. 24 plus 4 does indeed equal 28. We did it. Okay, now we gotta go find another spot. Okay, so I see a couple problems here. These are multi-step equations. Okay, so if I look at this one, I'm gonna have to combine like terms. So I have my 4x and my minus x, so 4x minus x is 3x. So I get 3x plus 7 is equal to 19. And then this looks normal. So I'll subtract 7. So I get 3x equals 12 and x equals 4. Okay, and I can plug it back in. If I put 4 here, 4 times 4 is 16 plus 7 minus 4. Does that equal 19? 16 plus 7 is 23, minus 4 is 19. Yay, we got it right. Okay, now we'll move over here. All right, so here we're gonna have to distribute. So I will take my 3 and distribute it through there. So I'm gonna get 17 equals 3p minus 15 plus 8. Ooh, now I also get to combine like terms. So I can look at my negative 15 and my plus 8. So this is going to turn into 17 equals 3p minus 7, and then I'll add my 7 to the sides. Get 24 is equal to 3p, divide by 3, divide by 3. P is going to equal 8. Okay, and I'll plug it back in up here. So 8 minus 5 is 3. 3 times 3 is 9 plus 8 does equal 17. Yay. Good job. All right, let's see what else we can find. If there's something strange in your equation, who are you gonna call? Fraction busters. Okay, so let's look at this problem right here. So let's look and see 3 and 4 and 12. They're all factors of what? 12, yes. We're gonna multiply each piece by 12, or 12 over 1. Okay, so if I take 1/3 times 12, I could cancel the 12 and the 3 and get 4 and 1. Okay, or you could just think 1/3 of 12 is 4. So we get 4w plus, and then 12 times 1/4, you can cancel the 4 and the 12 and get 3. So we have 4w plus 3 equals, and then here the 12s would cancel. So we get 4w plus 3 equals 5. Okay, and so then what we're going to do is we're just going to subtract the 3. And so we get 4w equals 2, divide by 4, we get w equals 1/2. Okay, that one wasn't so bad, right? Yeah, all right, let's go. Let's do another one. I hope I'm doing okay on time. Okay, and now solving with variables on both sides of the equation. There we go. All right, so notice here we have an a on the left side and an a on the right side. So we need to get all the a's on one side. Okay, so I'm going to move them all to the left side. So I'm going to get rid of 4 a's on both sides. So then I get 3a minus 17 is equal to 1. And now it looks like a problem that we've done before. So now we'll add 17, add 17. 3a equals 18, divided by 3, divided by 3, a equals 6. Ta-da! Perfect. Okay, then we have something like this. Okay, we're gonna have to distribute first. So we've got 2x plus 8 equals 3x minus 6, because we distributed that 3 through there as well. Okay, now I'm gonna move my x's to one side of the equation. I'll subtract 2 x's on both sides. So then I get 8 is equal to x minus 6. Add 6 to both sides. We get 14 is equal to x. X equals 14. Okay, we're almost done. Okay. Oh, I see some right here. Okay. Oh yeah, let's try this. Oh yeah, let's try this. Okay, let's do this one first. Okay, so I'm going to distribute the -2 through here. So I get -2x minus 4 equals -2x plus 1. Okay, so now I will add 2x to both sides. The 2 x's cancel out. I get -4 equals 1. Well, since -4 does not equal 1, that's not true, then that means no number can be plugged into x and make this true. Okay, so this would be no solution. Okay, no solution. So sad. Okay, let's look over here. I'll distribute the 2 through there. So this will say 2x plus 8 minus 5 equals 2x plus 3. And then I'll combine like terms here. So I get 2x plus 3 equals 2x plus 3. If I subtract 2 x's from both sides, the x's are all gone, and I just get 3 equals 3.
And since that is true, that means any number that you plug in for x will make this true. It'll be the same on both sides. Okay, so you could say many solutions or all solutions, or you can say all real numbers, or this is also called identity. Whoops, my circle was poor. But either all real numbers or identity. Okay, and that was the last one. Did I do it?
Did I make it? Did I do it? I did it. Woo!